Well, hello friends. Today we are going to work on kernel virtual memory stuff, and we're going to be implementing map private for mmap. And what that is that there are two ways that you can map files in Unix systems. So you can map them either shared or private, and that happens via the map, map shared or map private flag that you pass to mmap. And a shared mapping, when it comes to a file, is a mapping that can be seen in multiple processes. So if two processes map the same file with map shared, it means that they can both see each other's changes to that memory. Whereas map private creates a unique mapping, and you can change that, and it doesn't actually show up in other processes that have mapped the same file. And so, as we can see here, Andrew noticed that we were lacking support for this, and he ran into some trouble. And I've also had various situations where I wish I had map private. So I think today we're going to implement it, and it's not going to be optimized. So there's a lot of optimization that you can do with copy and write and things like that. But for the first cut, we're just gonna make it a simple, naive implementation that, in order to create a shared inode mapping, we'll just load the whole thing on immediately, I think, instead of trying to load it lazily and copy and write and stuff like that. And then we can build out with more optimizations later on. So how are we gonna do that? I guess I can lose this. So what we currently have is inode VM object. This class represents a VM object that is backed by the contents of an inode. And anytime that you memory map a file, you get one of these inode VM objects underneath the memory mapping that you get. Now, this thing is shared between all processes. So there's, for every inode, if you look at the inode class, we can see that he knows how to get back to his shared VM object. So this is the shared one that everyone participates in. But for private ones, we can't really use this, right? This is only useful for shared mappings. So I'm thinking maybe we'll split this class into shared VM object and private, shared inode VM object and private inode VM object. And maybe they could inherit from inode VM object, because maybe they can just be separate classes. Actually, let's just rename this guy to shared inode VM object. That was Alt-Shift-R, by the way. People keep asking me about my QCreator bindings and stuff. So, but I've set my bindings up manually. So this one was Alt-Shift-R for rename symbol on the cursor. This is a very nice feature. Of course, it doesn't always catch everything. So let's see if, yeah. So it doesn't catch comments, obviously. And sometimes it doesn't catch, well, it seems like maybe this one worked out. So maybe we didn't set the kernel flag. Okay. And so this is just a small change, but we'll start with that. And for inode, we could rename this getter also to shared inode VM object, or just shared VM object. I think that's pretty good. And since we're already here, let's do this one as well. So then, this one as well. Okay, there's so many. This way, we still have the feature where you can go from an inode to its shared inode VM object. Maybe we should actually do that. Why wasn't that more strongly typed already? Set shared VM object. Seems like such an obvious improvement, because the only person who calls this, which we can't even find, because the search and replace thing didn't catch it. It's right here. Yeah, so sometimes auto confuses the renaming feature, which is not perfect, but it is pretty good. So, all right, and then now let's also go and rename the files, since I guess maybe they're here. Shared inode VM object. Inode VM object shared. And are we done? Okay, well, that was unexciting, but kernel rename inode VM object to shared inode VM object. Okay, and now let's introduce a new class. So we'll copy the old one, private inode VM object, and we'll do that. And now we gotta figure out how this thing should work. Using the new RGB mouse here, by the way. And why does this keep showing up? I keep getting told that it's connecting and disconnecting from my Wi-Fi. But yeah, this RGB mouse really something else. Thanks again, Jesse. Okay. So we have a copy constructor, and what else? Interesting, super interesting changes, right? So I guess here we can have one of these guys. What do we do if it says inode true? Oh, all kinds of things. And if it is inode, then we're casting it. Okay, so maybe a shared base is not a bad idea. Let's do a shared base. Okay, we are flip-flopping a little bit here, but it's going to be okay. So, let's see what we do for that one. Can be, this one is not going to be final, so it's going to be inheritable, and these will be protected, and we won't let you construct one just like that. Okay, and this one will be final because all our subclasses will be inodes. Private inode VM object. So let's look at the shared one first, because that one we already know how it should be like. So shared inode VM object now inherits from inode VM object, and we don't need this, that, any of these. So it actually simplifies a bunch of things. And this is essentially, we don't want it to be movable. What is that? Make non-movable. All right. Oh, wait, how did I do that? Okay, I don't know how I'm doing that. And we don't need this, that, any of that. And apparently we have a copy constructor used by clone, which I guess we can live with. So that's a pretty tidy class. So let's go and look at sources. So we gotta call our base, which is now inode VM object. And our base needs the inode and the size t, right? And we just forward to him, yep. And then we don't need these guys because they're in the base. A lot of unfinished stuff here. Okay. That's really quite nice. And then let me change the copyright header so it just says 2020 because I don't want to act like I worked on this 2 years ago. Okay. And in the shared. Okay, now let's look at the private one. So, no, what am I doing? Let's say inode. And likewise, we don't need these guys. We can use non-movable for this guy as well. Don't need that. So I think that's okay. Now, of course, let's do the CPP file, or let's do it immediately because it's just a matter of removing stuff anyway. Then we should go and look at mmap. VM object. No. So this is going to be different for private, because when you create a private inode VM object with an inode, then now we're not going to tell the inode, hey, I am your shared VM object, because that doesn't make any sense when we're private. And we also should not look for the shared one and reuse it if it's available. Ploop. Instead, we can just do this. Okay, that's good. And here we'll just pass the arguments through. That's good. And that one does not make sense anymore, and then we lose these. So the logic is very, very simple. I mean, the difference between the two inode VM object types is very small, but that's okay. That's good, in fact, because that means that they're easier to reason about. And then I guess we could have, or let's not get carried away. So probably we're casting to shared inode in some places, so we gotta fix that up. So this guy right here, this is purging, doing purging all of the clean inode pages. So what this code is about, it's when you tell the system, you tell the kernel to throw away any memory that you don't need right now, then we will go through all of the inode VM objects and we will just release pages that are identical to the ones we have on disk, because we could always just reload those from disk. So that's what this code is doing. So I think we can just write the code this way instead. Yeah, that's okay. And we had one more place that was doing this. So we're getting an inode fault, and I think we're probably gonna set this up today so that we don't get page faults in private inode VM objects. I think maybe that would be okay. So now let's go to mmap, now that we have done all of this boilerplate action. Wait. Inode VM object. I did not rename all of these things. Poof. Look at that. Create with inode. You disappear. And you too. Don't need you. And these are fine. Okay, so finally we can go to mmap and look at the arguments. So the shared flag is here, but the private one is the one we care about today. So I think we're probably going to fail out somewhere right here. Yeah. So we have a fix me about implementing map private. Now we're just going to remove that failure code here, and we will instead continue on to wait, hold on, map private. Oh, I'm trying to follow what the code is doing. So if it's a purgeable mapping, then we do this stuff. If it's anonymous, it's this. Otherwise, we go down here, and this is the file back mapping code. So the way that it actually works is that we look at the file descriptor that you pass in, and then we dig out the description for that. And then we call the file description. He has a virtual, he has an mmap virtual wrapper thingy that just calls mmap on the file. And this is what creates the memory mapping. And if we look at how this is implemented, we can go to inode file, and we can see here that what this ends up doing is that it calls allocate file back region. And then it's not until we get deep into this code, and then deeper into this even, and then deeper into this even, I'm looking for the place where we create the VM object. Where the heck is it? Where are the constructors of these guys? Here. So the region constructor creates a shared inode VM object. Now that's a little bit of a mess. I don't like that much at all. So maybe let's do this in two separate steps. So let's put back the code that would fail to create these for now, and then we'll just commit these changes that we have. Kernel split inode VM object into two subclasses. We now have private inode VM object and shared inode VM object corresponding to map private and map shared. Note that private inode VM object is not used yet. Okay. And then because I wanted to go in and do something about this situation here, because it's kind of irritating that the VM object for this memory region is created in the region constructor. Now we have this other region constructor that just takes a VM object that's provided to him, and it would be kind of nice if we could be using this one instead, because it seems like they're equivalent otherwise. So I think we're just going to get rid of this guy and then force callers to instantiate a VM object instead, because it's just fine for the callers to be doing this. Then we don't have to like push this logic into the region constructor, which is a really awkward place for it to be. So we'll get rid of this region that takes an inode. Very strange. And then we'll just try to build and see what breaks, and we'll have to fix that. Alright, hurry up a little bit. So I got the new hard drive, by the way, also. In addition to the RGB mouse, I now have the /zoom, which is where I mounted it. Look at all that space. Just been moving some things over there to make space on my regular root partition. Very, very good. So much space now. Now all we need is time. So, where are we? Region 201. 201. Okay, so create user accessible. This is the guy. So this is just a helper that takes an inode. So we'll get rid of him as well. It's an awkward function anyway. Create user accessible. So who's been calling this? I see one right here. Maybe it's him. Process 213. Yeah, that's the one. Allocate fileback region. So, and this is the thing that inode file is calling. So now we are way closer to the action. And we can here make the VM object that we want. So allocate fileback region. Who else calls this? Does anybody else call this? It's just this one thing. Okay. That's good. That means that we can probably consolidate this with something else. How about we consolidate it with allocate region with VM object? Because why does it need to be any different? Allocate region with VM object. Can we do it this way? Like allocate region with VM object. Then we need to pass in a range. So wait, we have this thing down here that we can call. Allocate region with VM object. Okay, I'm just gonna go down here so I can see what I'm doing. Valor, size, shared inode VM object, create with inode, name and proct. So are these things equivalent, or do I need to do that also? Okay, what's wrong? 5 is bad. Am I missing some argument? Yes, the offset. Guess I'll do that. So this seems like a mistake, by the way. Fileback region. Why does it not take care about the offset? Oh, see? We don't allow you to mmap at any other offset than 0 at the moment. We just assert if you try to do that. That's not super good. but that means that we could probably do this stuff out here instead. So we could say region is process. And say offset. And the name is the file description, absolute path. And inode like that. Okay, and then we just need. So I'm going to make this use shared VM object now because I'm just refactoring this thing to make a whole bunch of unnecessary layers go away. Because it seemed like unnecessarily cumbersome to create a file-backed region, because this helper was really just used in one place, so we're getting rid of it. Alright, so now inode file can directly call allocate region with VM object in inode file mmap. This seems to be the same thing as other devices are doing in their mmap implementations. So this is actually really good because now different files use the same function in their mmap implementations. So it's good. Good thing. So if this builds and works, then we can move on to caring about the private file-backed. Yeah, I got rid of all that. Is this a net negative? 5 insertions, 35 deletions. Now that's a good patch, right? Like mostly red. That's really nice. Look at all that red. Look at that awkward style change. I don't want that style change. Dang it. Don't pollute me with your style change, bro. Oh, yeah, that's nice. 3 insertions. And let's just see that it works still. All right, we are up and we are fine. That's good. So, kernel. Remove some unnecessary indirection in inode file mmap. Now, inode file calls directly to process allocate region with an object. Now directly calls, instead of going taking an awkward detour via specialized region constructor via a special region constructor. Okay, that's really nice. Because now, in order to implement the private flag, we can go here, because currently we only get the protection settings and other metadata, but we don't get any of the information about what kind of mapping this should be. So, I mean, since we are a file, we can assume that it's a file mapping, but we don't know if it should be private or shared. So I think we will take it as a flag, shared, and that means that we have to update all the other guys, but that will be easy enough. Ooh, shared. No biggie. And should actually do something with this flag for the other guys as well. Because I guess, I mean, no, maybe we shouldn't. Maybe we should fail unless you map these as shared, because this, for example, is a video card frame buffer, right? And if you try to make a private mapping of that, that doesn't really make sense. Like, you want your changes to be reflected in the underlying video memory, right? So I think probably what we should do here is say if not shared, then return enodev. And we'll do the same in the other video card implementation. Because we're not the kind of device that can be mapped privately, bro. Alright, that's pretty good. And then this guy needs to know what to do, so we'll pass it along, and we'll take it in from somewhere. Okay, we're almost there. Oh, shared. File description. So now we just have to create the inode VM object based on this. So is it possible to do it this way, I wonder? Yeah, these are not compatible, all right. If shared. That's VM objects that. Okay. We should probably allow these things to fail. So right now these cannot fail because they return non-null ref footer, but we should probably get to a place where these would be allowed to fail. So I'm gonna set this code up here for handling that scenario. So if not VM object return key result mem. There are various kernel data structures that assume that you can never fail to allocate them, but it seems like a stretch in some cases. Like, we should probably allow this type of thing to fail. And, oh, we forgot to actually pass this flag to mmap, which I guess is the little red we have here. Yep. Map shared. Okay. And then we don't fail like that. And let's just verify that everything still works. And we are up and running. Okay. So now we're going to need a test program. Call it M. Let's just get the basics stuff. And what are we going to do in this program? Well, we are going to get ourselves some memory. We'll get exactly 1 page of it, which I like writing that way. Prot read, prot write, map file, map private. And we'll take the file descriptor that we get from somewhere. So we'll open, I don't know, like bin id, for example, for read-only. And we should be able to make a writable private mapping of it, I would think. Right? Yeah, we should be allowed to do that. Okay, so let me just quickly fail if we fail. So it's just good to do these things, otherwise you have some error and you don't know what it is because you're not printing anything. Alright, and now the moment of truth that we should say P0 is X. And we should assert that P0 is still X. And apparently I need assertions. So that's good. And now, to verify that everything's going the way it's supposed to, we should be able to do a second mapping of the thing. So I guess we can map the same thing just in a different way. So this one will be called the P private, P shared, and then the rest of it is going to be very much the same, except that we map it shared, map shared. I feel like the access control is going to fail us because we're going to be trying to map a read-only file as writable, and even though that should be allowed because we're private, it's not going to understand. So we'll see when we get there. Assert P private 0 is not P shared 0. This should be different, but the rest of them should be good, like that. Okay. Okay. So let's test this out. Right, permission denied when doing the map private. So that's expected. That's because we're asking for a writable mapping. So we have to take care of that in sys mmap. So where do we do this? This is here. So I think the correct thing here is to say if map shared and, because then we should only validate in these ways if map shared And the same thing here, probably. Map shared. If map shared. Okay, let's move all this under here together. Right, and then here now we have to pass in map shared. And then here we just have to pass in wait, I'm not doing that right. Hold on. Is shared. Oh, jeez. What am I forgetting? Something up here. Oh. Because this is just shared code between mmap and mprotect, so that we have the same logic if you try to mprotect something to change the permissions of a mapped page. So now that will be based on whether the mapping is shared or not. So you won't be able to remap a private mapping as writable if it's you will no hold on, I'm saying it wrong. You will be able to remap a private mapping as writable, even though the underlying inode does not allow writing, because we're not going to write it out to disk, or we're not going to publish it to other people. All right, so now map shared is permission denied. What's up with that? Map shared. Because I have prot write. Well, that's obvious. Of course, we're not loading anything yet, so it's still not going to work. Although it did work. Why did it work? Damn it. Oh, wait. In the fault handler, handle fault. Okay, so let's look at the inode fault. So we get a fault here in this region, and then we just ask the VM object, which is unique now. Oh yeah, right. So we have a separate VM object. Oh, so it can actually be lazy. So we can do laziness quite easily, but copy and write, it's trickier, because then we have to share the pages with between the shared and private VM objects. But we can do this. I kind of have to sneeze. Oops. Sorry about that. Yeah. So I was a bit mistaken there. This is good. So now we have two completely separate and distinct inode VM objects. We have one private inode VM object for the map private mapping, and we have one shared inode VM object for the map shared mapping. And when we get a page fault, then we just look at the underlying VM object of the region that we faulted in, And since those are two distinct VM objects, then they also maintain their own physical page mappings, and they both of them will just go to disk and fetch what they need. So I was getting confused about this because I was thinking the old way that like, oh well, all VM objects that are inode backed are also shared between multiple regions, but that's not the case here. So I guess this was a bit easier easier than I was expecting then. But that's really neat. So let's say I'm sure that I've made some blunder here somewhere, but the general mechanism seems good. Now I made that stupid change again. Ugh. I don't want to make that change. I hate when I make those changes by mistake. Oh, that looks even worse. Okay, let's commit kernel. Implement basic support for sys mmap with map private. Can now map mmap a file as private and writable, and the changes you make will only be visible to you. This works because internally a map private region is backed by a unique private inode VM object instead of using the globally shared inode VM object like we always did before. Man. Alright, so that actually turns out really nice. Let's go to sleep here and then see what this program looks like in the system monitor, because now I'm kind of curious, because I bet we're not going to visualize this very well. So okay, now we have the M program right here, and we have bin.id. So this one is mapped read-write, and this one is mapped read shared. And both of them are fully populated. That's rather strange. Why are they like that? I'm surprised about the black. Okay, let's go and look at these in the... wait, what does it say about resident? Oh shit, right, it's we only map one page. And I read from the page and I touch the page in both of them. Right. That's why it's like that. Because I was thinking, I thought I was mapping the whole file, but actually I don't. I just map the first page. So we could map the whole file. It would be this many bytes, so 170020. Sounds a bit like a phone number. So we'll do that, and let's see what it looks like. Alright, now we have bin.id, and both of them have like a little bit of black at the left here, which means that they both have physical memory for one page, essentially. And then the rest of it is not loaded. That's so neat. I really like it. And I guess we do actually visualize the fact that this one is shared and this one is private. Although maybe it could be more visible because S is, it's the fact that the region is shared, not the underlying VM object, because these guys are shared as well, but we don't see that here. Should we see that there? I wonder. It's a little bit weird. I'm not quite sure. It's weird. It's weird because we have so we have a shared flag on VM regions, and each one of these guys here is a region, and they have a shared flag. That's the one that you see here, the S, and T here is for stack, by the way. So it's kind of weird because we have shared and stack. Both of them start with S, and I just shared was the first one I put in, so he became S, and then stack got the second letter instead. But anyway, I'm just thinking now that the region can be shared, but you can also have a shared underlying VM object backing your region. It's a little bit unclear to me what would be the best thing here, because it is relevant to me that these guys right here, that they are backed by shared inode VM objects. I guess one thing we could do is we could allow you to see here exactly what class this is that's backing the thing, like VM object class. That might be interesting. Why don't we show that? Does VM object know how to say what class he is? He does not. Well, we can teach him. So we can just have a const char class name. Const pure. And then in shared inode VM object, we will const override return shared inode VM object. So, oh, I forgot to make this virtual. Private. When I'm making, by the way, this is a subtle thing here. Whenever I'm making some function like this that returns something type specific about a type and it's a virtual thing, then I like to make it private. And the reason I make it private is because if you have a pointer of this type and you would be calling class name on that, then you're being a little bit silly because based on the type name, you already know that it's a private inode VM object. So by making this private, the compiler will tell you like, hey, you don't need to be calling class name on this thing. You know what it is. So it's just a little weird little habit that I picked up a long time ago. And then we need anonymous VM object to have these things. Put this down here, whatever. Anonymous and purgeable. Oh, this one actually needs to be protected because this guy has a subclass, which is the famous purgeable VM object. Purgeable. Okay, and now in procfs we can go in pidvm, and when we log all of these regions, then we can also include VM object. You can just say VM object, actually. Class name, just like that. And then in system monitor main, or no, in the process memory map widget, we Oh, now we have to go into user space mode. And we can add a new field for this, so I'll just put it in maybe before cow. Let's say VM object. VM object type. Make it left aligned, and now this is going to be a bit of a big rebuild. But I think this will be nice, because then we can see what kind of VM object is underlying this thing. Somebody asked in a comment the other day if I'm like sort of having a little bit of a feature creep in the system monitor, just adding more and more features for process introspection and stuff. And I feel like we're still in okay territory. We're definitely adding a bunch more features to it, but I do kind of think that these are all the kind of things that you want to have very visible. So my thinking is, if I put this kind of stuff in System Monitor, it means that I see it way more often, because I just bring up System Monitor to see what a program is doing, and this allows me to see a lot more about what the program is doing. Simply by showing me more info, more like dense information. And my hope is that by surfacing more information like this, I will build a better understanding of the system as I use it and as I observe it. But this is not really scientific. It's just me and my intuition playing around. But I really do like the fact that now we can see what type it is. Although it does feel kind of redundant that we say VM object after each one like that. So we could just strip it, I guess. We can leave that as an exercise for later. We don't have to do that right now. So let's see. Wait, hold on. Commit kernel. Expose VM object class name. Expose the VM object type of each region in proc id VM. System monitor, show VM object class names in process memory. VM object types. You know, you could probably even come up with some nice icons for these. Show me something that's mine. That's interesting. I like it. Definitely like it. Maybe it should have been over here. Maybe it should have been over there. Move. Sweating the details here. Oh, shit. What did I even do? I don't know. We're just gonna... Okay, wait, hold on. Oh, right. This guy. This guy's sensitive to the indices. It's a little awkward because it's the column index of the page map that I did the other day. So... yeah, this is a little better, actually. Cool, 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 cool. I love having more information. Information makes us smarter. So I guess now it's like time to start using this in more places. But I'm not gonna propagate it in this video. Just wanted to get to this point. And now we are here. See, we have a private inode VM object backing this one mapping of bin ID and is writable. And we wrote to it. And it didn't show up in the shared one. Cool, cool, cool. Okay. I'm very happy. So I think this is going to be the end of today's video. This got pretty low level, pretty specific about VM stuff. So if you made it this far, then I thank you for watching. And I hope you saw something interesting. And maybe you saw me make a mistake and you can exploit it and hack the system. What do I know? But this is definitely going to need to be refined a bunch. But I'm glad that we at least have private inode mappings now. It's really cool. And yeah, I'll see you next time.